You ever just look at a tree and wonder what's really going on inside? I mean, not just its slow growth, but its daily, moment-to-moment life? Well, today we're going to look at some absolutely incredible science that lets us, for the first time, listen in on the secret, silent pulse of an entire forest.
Okay, so what in the world are we looking at here? This is not some futuristic theme park ride. This is a high-tech, ground-based radar system. It's hanging from a tram that glides through the Harvard forest, and its whole job is to eavesdrop on the trees right below it.
And that really gets to the heart of it, to this one big, fascinating question. What if we could measure the vital signs of a whole forest, its collective heartbeat, in real time, without ever having to touch a single leaf?
Now, to really get why that's such a huge deal, you first have to understand just how difficult this is. I mean, we're talking about trying to see inside a living, breathing, incredibly complex organism.
You know, a tree is basically a giant organic plumbing system. It's constantly pulling water up from its roots, all the way to its leaves. For decades, the only way to really see how that works was to, well, drill into the tree and stick sensors inside. So the big challenge has always been, how can you possibly watch this system in action without damaging it?
Well, the answer, it turns out, comes from a brilliant team at the University of Massachusetts Amherst. And it all comes down to a really clever use of radar.
See, by putting their radar on this 50-meter-long tram, the scientists can scan the exact same set of trees over and over and over again. It's like creating a time-lapse, but for the inside of the forest. And that consistency, that's the absolute key to spotting the tiniest little changes.
So how's it actually work? It's surprisingly simple in theory. First, the radar sends out a weak radio wave. Then, step 2, it listens very carefully for the incredibly faint echo that comes back. And third, this is where the magic happens. It analyzes how that tiny echo changes over time.
Now, the really tricky part here was the engineering. The echo coming back from the water inside the tree is just minuscule. It's a whisper. The radar's own electronics, though, are a shout. So the biggest hurdle was building a system sensitive enough to hear that whisper over its own noise, a problem they call self-interference.
Okay, so the radar is listening for change, but what is it actually hearing? Well, it turns out that water has a special property, kind of like a superpower, that makes it stand out to radar waves.
It all comes down to something called the dielectric constant. Now, don't get hung up on the name. Just think of it as a reflectivity score. Every material has one, but water's score, well, it's off the charts.
And this chart really shows you why that matters. Just look at this. Liquid water has a reflectivity score of around 80. It's like a mirror for radar signals. But look what happens when it freezes. Ice plummets all the way down to 3. A living tree, which is full of water, sits at about 15. It's this massive difference that the radar can so clearly see.
And this is the moment it all clicked. So the radar is just listening, day in and day out. As winter arrives and the temperature drops below freezing, that water inside the tree starts to turn to ice. As it freezes, its reflectivity score tanks, and the radar signal changes perfectly in sync. By tracking this freeze-thaw cycle, the scientists proved, without a doubt, they were actually seeing the water inside the tree. They had found the forest's pulse.
Now, to make sense of all this incredibly complex data they were getting, the researchers turned to a really powerful analogy, one that anyone in electrical engineering would recognize right away.
They started to think of the tree as a biological circuit. So, the flow of sap, that's just like electrical current. The pressure that pushes the water up the tree, that's like voltage. And the amount of water stored in the tree's trunk, that's like the charge held in a capacitor. This analogy was a game changer.
So this new way of thinking, seeing the tree as a circuit and being able to measure its water, suddenly opened the door to an even bigger, more exciting possibility.
Right, so they can see how much water is in the tree. That, right there, is a massive breakthrough. But the next question was the real prize. Could they use this thing to measure the actual movement of the water, the sap flow itself?
And incredibly, the answer was yes. Using something they call differential mode, they figured out that they shouldn't just look at the signal itself, but at how fast it was changing. Think about it like this. It's the difference between knowing where a car is and knowing its speed. That rate of change in the signal corresponds directly to the sap flow. So, how well did it work? Unbelievably well. When they compared their radar measurements for sap flow against the old-school in-ground sensors, the relative error rate was just 0.12.
That is a stunningly accurate result and a huge win for this new technique.
This is all really cool science, for sure. But so what? Why does listening to a forest's pulse actually matter to us in the real world? Well, the applications are just massive. By watching a forest water use this closely, we can start to predict how it's going to handle a drought. We can get early warnings when trees are stressed, which is a huge factor in wildfire risk. We can even get a much better handle on how forests pull CO2 out of our atmosphere, which, as you know, is a huge part of regulating the global climate. So we end up right back where we started, but now with a completely new perspective. For the very first time, we have a tool that lets us listen to the inner life of our planet's forests without ever causing them harm. And it leaves us with one final, and I think really important question. Now that we can finally hear them, what are they trying to tell us about our future?